Hey class, last video of this week we're looking at tension examples from basically, I'm going to pick one from practice sheet number 1, basically the two body problems with no angles, and then I'll pick one from the two bodies with angles, and we'll go over just tension examples. Now, to find the tension, I need to find the acceleration anyway, so this is going to kind of be also a little bit more extra review of how to find acceleration from two questions, but then I'm going to focus in at the end about just the tension itself and how it works out. So I'm going to take these right from the practice questions. So for the first one, I'm going to do in practice sheet number 1E, and it looks like this. We have a mass of 40 here. We have this mass of 25, a little pulley here. All right, and so let's see what happens. We have a mu of 0.40. All right, so let's kind of figure out what do I need. Again, tension here is going to be mass times acceleration. All right, now this one, let's just kind of think of what's going to be happening. This is obviously going to be moving down. Technically, it could be actually, like if friction's winning, again, we could have this stationary. But even still, that means the tension, which mass are we going to care about? We care about this one, because this is the one doing the pulling. This doesn't want to move. There's friction. It doesn't really want to move. So this is the actual mass that's pulling. So I can kind of put down 25 here to start off with. Now we have to figure out kind of this scenario. Okay, there's going to be some gravity in here, and there's going to be also an acceleration. I'll finish that part kind of at the end. Let's kind of go through how to figure out this acceleration. Well, let's get the force of gravity of, I'm going to put this as A and this is B, of A here, and I get 40 times 9.8 gives me 390. So 390, that's what I get. 392, I bet. 392, which is also then going to be the force normal for this one. So now I can find friction. Force of friction right here is going to be 392 times 0.40. So my frictional force of this, because there's no angles right now, is going to be 156.8. 156.8. All right, cool. Let's figure out force of gravity B, which is just 25 times 9.8. So I do that and I get 245. And those are all the forces that I have involved here. All right. I have this, which is going to have a force of friction, which is slowing down. There's my force of friction. And then I have this here, which is my force of gravity for my B. So to get net force, I'm going to go this force B, 245 minus 156.8. My friction, and I get 88.2. There's my net force. Let's actually get my acceleration, which is I'm going to use my total mass. Because these are tied together, there's a total mass. So acceleration equals 88.2 divided by 65. I have an acceleration of 1.36. 1.36. Okay. So there's my acceleration. All right, so there's a little review of how to do this type of question. Now, let's go through how to find tension. Let's say this thing was not moving. Let's say it was stationary. Okay, the 25 would be pulled by an acceleration of 9.8 because gravity wants to pull it down. Now, if this thing does start moving down, the rope should have to do less work. Because let's say this thing was actually moving at 9.8. Say it was moving at the exact same speed as gravity. That means that rope's doing nothing. Gravity would be pulling it down to 9.8. It is moving at 9.8, so the rope would be doing nothing. So actually, the more acceleration that you have here, the less work the rope has to do. So that's how we're going to show this in this equation here. We'd have 9.8, but it's going to be minus 1.36. Because as I accelerate faster, this rope has to do less and less and less work. Okay? And so that's how I find tension in this one. Mass times acceleration. And so, again, acceleration, we're going with gravity. When we go with gravity, we usually take our gravity, like a 9.8, minus our acceleration of the actual problem here. So let's actually figure this out. When I do that, I get 25 times 8.44, and I get tension of 211. 211. Okay, So there's our first problem. There's our problem from example of practice sheet number 1. Let's go through example sheet number 2. And this will be question 2. Question 2 from your actual two problem polys, two body problems number 2, like the second practice sheet, the one with angles. And so this will be question 2 of that. So let's go through this one. We have a mass of 2, kind of doing this, mass of 5, angle of 40, and we have a mu, I think, of 0.35. All right, so we got to break this down into a few different things here. Let's kind of go through this. So we have, I'm going to put A, B, force, gravity, A equals 19.6. All right, now we got to break this into force normal. Okay, and I'll do some colors here. We have, when we break this apart, force normal this way, and we're going to have force parallel. Ooh, that's very light. Can you see that? Yeah, kind of. I'll only use this for this. Force parallel here. Okay. To find force parallel. Okay, and I'll put this in nice actual colors here. Again, force normal is cos theta. Force parallel is sine theta. Okay, times force gravity for both of them. All right, so let's go with force normal. Force normal equals cos of 40, okay, times our 19.6, and force normal is 15. That doesn't sound right. Force normal, no, I'm right, 15. That does sound right. Force normal is 15, okay? And so with that force normal now that I have the force normal, I can find my friction. So I'm going to find my friction right now. Friction equals force normal times mu, so 15 times 0.35, and I get 5.25. So friction is going to want to pull with 5.25. All right, let's go with force parallel. How much does this want to go down the ramp? That's my sine times theta times force gravity, and that'll give me 12.6. All right, so we kind of have two forces on this one pulling down, okay? Possibly. We don't technically actually know yet. We just know the force parallel is doing this. 12.6. That's my force parallel. What is this force? Force gravity B. 5 times 9.8 is 45. 49. A little off. Force gravity B. 49. So we know that this is bigger than my force parallel, which means gravity is also going to be going in this direction. There could be other questions where this is pulling this and this is going up, which means if that happens, force parallel is going this way, okay, and then force friction will be like in this direction because this would be bigger, okay? Whichever, when you compare force parallel and force of force of gravity here, whichever one's bigger, force of friction is going to be going in the opposite direction. So it wants to go this way, which means force friction is going this way. So I have another force of friction of 5.25. Okay, so let's do our net force. Net force equals 49 minus 12.6 minus 5.25. I get a net force of 31.1. 31.1, and I get an acceleration of 31.1 over 7, which equals 4.44. All right, so there's our acceleration. Again, which way is this going to be going? The 5 is going to be the pulling aspect. Because it's going this way, okay, the 5 is going to be the pulling aspect. Also, it's the one that's actually like in the free. It's not on a frictioned surface. So this is the one that's going to be pulling, so our mass is the 5. So torque equals mass of 5 times what acceleration? Again, this is going with gravity, which means the rope has to do less work. Okay, if there's no extra acceleration, gravity pulling down at 9.8. Because it's moving, we can take that 9.8 minus 4.44, and that'll give me 5. And then what's there? I didn't write that down nicely. I can do that with my calculator here. If I have a calculator here, there it is. All right, so 9.8 minus 9.8 minus 4.44, and I get 5.36. And tension equals 26 something, 27. For some reason I didn't want to do that last part. So 5 times 5.36, 26.8. 26.8. And so there's my tension for this one. Okay? Now, just as a last little thing, because I think this happens once, if in the scenario where it's going this way, okay, you still have the mass of 5. That's still the one that's actually moving. Okay, so your mass is to be 5. It's not the one on the friction object. But you would be going 9.8 plus whatever, because now you're going against gravity. Okay, kind of like on our first questions, okay? If the object on the rope is going up, it's going against gravity, there's going to be extra acceleration. If it's going with gravity, there's not as much tension. And so that's how tension gets affected. All right, class, hopefully that made sense. If you have any questions, let me know. Thanks.